Hey guys, it's Michael here from FlySight. In previous videos, we talked about how we build energy for a high-performance landing and how we retain that energy through the transition to horizontal flight. In this video, I want to show you how you can measure the outcome of that process. One key thing to keep in mind is that our motion across the ground is strongly affected by wind. If we land downwind, we will fly faster and further than if we land upwind. FlySight Viewer can subtract the effect of wind, but when you're close to the ground, it's difficult to do this accurately, so it's better just to treat these measurements as wind dependent. Let's jump straight into FlySight Viewer. As usual, we load a track and zoom into the landing. We can orient ourselves using the top view and the side view. Here's our landing maneuver, where we reach our maximum vertical speed. In the side view, we can see that our track is vertical at the cursor. Next, we transition to horizontal flight. Our maximum horizontal speed, shown in red, occurs just before horizontal flight. Finally, we can identify the start of horizontal flight by looking for the point where vertical speed hits zero, around here. Before we continue making measurements, I'm going to set the ground elevation manually by hitting N on the keyboard and then clicking where the jumper has come to a stop. This way, we know exactly what point our elevations are measured relative to. When vertical speed hits zero, our altitude is about 3 meters. We should take this value with a grain of salt. There's some error in vertical position, which we can quantify by looking at the vertical position accuracy plot. In this case, our vertical accuracy is about 5 meters, so we shouldn't take the altitude measurements too seriously. In general, velocity measurements are more robust than position measurements. Our horizontal speed at this point is about 100 kilometers an hour. Finally, we can measure the distance traveled between this point and the point where the jumper touches the ground. In this case, we see vertical speed drop just before horizontal speed drops, because the jumper hits the ground first and then slides for a bit. Ground contact will be the point where vertical speed hits zero and horizontal speed starts to drop quickly. We could verify this with outside video. Using the measurement tool, we see that the total distance from the start of horizontal flight to ground contact is about 99 meters in this case. That's it. As always, I'd love to know what metrics you guys are looking at, and if you have any questions, please let me know in the comments. Thanks for watching.